There is a moment standing beneath a clear sky far from any city, when the night feels generous. The stars appear in their thousands, scattered across the dark with what seems like intention, like abundance, like proof that the universe is a place filled with things. Your eyes move from one point of light to the next, and the impression is overwhelming. The cosmos is crowded, ancient, burning, alive. Every direction you look, something is there, something is shining, something is close enough to see. You are one of the few structures in the universe capable of knowing it exists. While that window remains open, subscribe to Beyond the Universe. The void can wait, but that feeling is a lie your nervous system tells you because it has no other language for what it is actually seeing. The human eye was not built for cosmic distances. It was built to judge the gap between a predator and a tree, to measure the width of a river, to read the expression on a face a few feet away. When it looks at the night sky, it does the only thing it knows how to do. It flattens everything into a single surface, a kind of ceiling, and it reads that ceiling as nearness, as presence, as company. What it cannot tell you is that the star you are looking at may be so far away that the light reaching your eye left its source before your species existed, that the light from another star left before the first human hand pressed itself against a cave wall, that some of the faint smudges you might mistake for nearby clouds are entire galaxies, each containing hundreds of billions of stars, and they are so far away that the distance between you and them is not a number your body can feel. It is only a number your mind can write down and then stare at without comprehension. The night sky is not a ceiling of lights. It is a record of separations, a record of distances so vast that the word vast fails immediately. And if you want to keep following the places where science begins to lose its certainty, where the numbers stop being comfortable and start being something closer to dread, stay with Beyond the Universe. Because what comes next is not a story about how full the cosmos is. It is a story about how empty it already is, and how much emptier it is becoming. Begin with a single fact, and let it settle. If you were to take all the matter in the observable universe, every star, every planet, every moon, every asteroid, every cloud of gas and dust, every particle of hydrogen drifting alone in the dark between galaxies, and you were to spread it evenly across the total volume of space we can observe, the average density would be almost nothing. Not thin, not sparse, almost nothing. A few atoms per cubic meter, in the most generous estimates. In most of the universe, even that is too generous. The true average, when you account for the vast regions between galaxy clusters, approaches something so close to absolute emptiness that the difference between it and a perfect vacuum is nearly philosophical. This is the universe you live in, not the one the night sky suggests, not the one that feels populated and warm and full of burning things. The real universe is, by almost any measure, a structure built almost entirely out of nothing, with thin threads of matter clinging to the edges of enormous absences. The absences have names. Astronomers call them voids, but that word is too small, too casual, too easily dismissed. A void in everyday language is a gap, a missing piece, a space where something used to be, or should be. The cosmic voids are something different in kind. They are not gaps in a structure. They are the structure. They are the dominant feature of the universe at its largest scales, and the matter, the galaxies, the clusters, the filaments of luminous gas and dark material that we can observe, those are not the main event. They are the decoration on the walls of something far larger and far emptier than anything they contain. To understand the shape of the universe at its grandest scale, you have to let go of the image of stars scattered through space. That image is true at small scales, the way a map of city streets is true at the scale of a neighborhood. But zoom out far enough, and the city disappears into a continent, and the continent into a planet, and the planet into a point of light that tells you almost nothing about the streets below. Zoom out far enough in the universe and the individual stars vanish. Then the galaxies blur into points, and what you begin to see is something that looks less like a scattering and more like a web, a cosmic web. Thin, bright filaments connecting dense nodes with enormous dark regions between them that contain almost nothing at all. The filaments are where the galaxies live. They are where the gas pools and cools and collapses into stars. They are where the light comes from. But the filaments are thin, and the voids between them are not. Some of the largest known voids in the observable universe span hundreds of millions of light years across. Hundreds of millions. A single light year is roughly 9.5 trillion kilometers. Multiply that by 100 million and you begin to approach the width of one of these empty regions, a region where, if you were somehow placed at its center, you might look in every direction and see almost no galaxies at all. Just the faint, distant glow of the filaments at the edges, So far away they would appear as nothing more than a slight brightening of the dark. Standing at the center of a cosmic void, if such a thing were possible, would be the most isolated experience the universe could offer. Not isolated in the way a person feels alone in a room, isolated in a way that has no human equivalent. The nearest galaxy might be tens of millions of light years away. The nearest star outside your own galaxy, if you had one, would be unreachable within any timescale that has meaning. You would be inside a bubble of nothing so large that the word inside would lose its comfort. There would be no walls, no edges you could approach, just the slow realization that the emptiness extends in every direction farther than light can travel in a human lifetime, farther than light could travel in the entire history of civilization, farther than almost any scale your mind can construct. But here is the first contradiction that the night sky hides from you. The voids are not passive. They are not simply regions where matter forgot to gather. They are regions that are, in a sense, pushing. The large-scale structure of the universe, the web of filaments and the voids between them, did not form randomly. It formed through a process that began in the earliest moments after the universe's birth, when tiny fluctuations in density, smaller than anything you could measure with any instrument you could hold, began to grow. Regions that were slightly denser than average pulled matter toward them. Regions that were slightly less dense lost matter to their neighbors. Over billions of years, this process amplified itself. The dense regions became denser. The sparse regions became sparser. The web emerged not from chaos but from the slow, relentless logic of gravity, acting on the faintest initial differences. The voids, then, are the negative image of the filaments. They are what is left when gravity has spent billions of years pulling matter away from certain regions and concentrating it in others. They are the universe's way of showing you what it looks like when structure forms, not by filling space evenly, but by evacuating most of it. The universe does not distribute itself. It concentrates itself in thin, bright lines and leaves the rest to silence. And the silence is winning, not in any dramatic sense, not with any sound or event or visible catastrophe, but in the simple arithmetic of scale. The voids occupy far more volume than the filaments. If you were to randomly place a point somewhere in the observable universe, the overwhelming probability is that it would land inside a void, not near a galaxy, not near a star, not near anything that glows or moves or changes. It would land in the dark, in the cold, in the vast negative architecture of a universe that is mostly made of its own absence. This is the first thing the night sky does not tell you. It shows you the filaments. It shows you the nodes. It shows you the bright concentrations of matter that happen to emit light in wavelengths your eyes can detect. It does not show you the voids, because the voids, by definition, have almost nothing to show. They are invisible not because they are hidden, but because there is almost nothing in them to be seen. And because your eyes can only register what is there. You build a picture of the universe from the exceptions, from the rare bright places, and you mistake that picture for the whole. The whole is mostly dark. The whole is mostly empty. The whole is mostly a structure of absences so large that the bright parts, the parts you can see, the parts that feel like the universe, are in truth a thin residue clinging to the edges of something that has no light and no warmth and no name that carries any emotional weight. But it goes deeper, because even the matter you can see, even the galaxies and the stars and the gas clouds that make up the luminous universe, even those are not what they appear to be. The light you receive from a distant galaxy is not a complete picture of that galaxy. It is a record of what that galaxy was doing when the light left it. If the galaxy is 1 billion light years away, you are seeing it as it was 1 billion years ago. If it is 10 billion light years away, you are seeing it as it was 10 billion years ago, when the universe was young, when the stars were forming at rates that have long since slowed, when the cosmos was a different place entirely. The night sky, then, is not a snapshot of the present. It is a layered archive of different pasts, each distance corresponding to a different era, each point of light a message from a time that no longer exists. The star you see may have already died. The galaxy you observe may have already merged with a neighbor, its shape transformed beyond recognition. The light reaching your eye is ancient, and the source of that light has moved on, aged, changed, or in some cases ceased to exist in the form you are observing. You are not looking at the universe as it is. You are looking at the universe as it was, across a range of different pasts, all arriving at your eye simultaneously, all compressed by the limitations of light speed into a single image that feels like the present, but is in fact a collage of history. The night sky is a museum. Every exhibit is from a different century, and the museum is so large that some of the exhibits are from eras so remote that the universe itself was a different temperature, a different density, a different kind of place. This is not a poetic exaggeration. It is the literal consequence of the fact that light travels at a finite speed. Nothing in the universe communicates instantaneously. Every signal, every photon, every piece of information about the state of any distant object takes time to arrive. And in a universe as large as this one, the time it takes is not negligible. It is, in many cases, longer than the age of the Earth, longer than the age of the Sun, longer than the time it took for the first complex life to emerge from the chemistry of a young planet. So when you look at the sky and feel that the universe is present, that it is here, that it is surrounding you and filling the night with its abundance, you are feeling something that is technically false. The universe you are perceiving is a ghost image, a projection of states that no longer exist, arriving from distances so great that the sources have had billions of years to change since the light you are receiving left them. The universe is not surrounding you. It is sending you old mail from addresses that may no longer be occupied. And this leads to something more disturbing, because the light that is arriving now, the light that is currently crossing the space between distant galaxies in your eye, that light left its source at a time when the universe was smaller than it is today. The universe has been expanding since its beginning, and as it expands, the distances between things that are not gravitationally bound to each other grow. The light that left a distant galaxy billions of years ago has been traveling through a universe that was, for most of that journey, actively growing larger. The space the light was crossing was itself expanding as the light crossed it. This means that the distance the light actually traveled is not the same as the distance to the galaxy today. The galaxy has moved, not through space in the conventional sense, but because the space between you and it has grown. The light that left it when it was, say, a few billion light-years away, has arrived at you after the galaxy has receded to a much greater distance. The universe is not static. It is not a fixed stage on which objects move. It is a dynamic medium that is itself changing, and the objects within it are carried along by that change whether they choose to be or not. The expansion of the universe is one of the most confirmed and most counterintuitive facts in all of science. It does not mean that galaxies are flying through space away from a central point. There is no central point. Every point in the universe is, in a sense, the center, because the expansion is not a motion through space, but a growth of space itself. Every region of space is growing slightly larger, and the effect accumulates with distance. Nearby galaxies, bound to us by gravity, do not recede, but galaxies far enough away, beyond the reach of any gravitational connection, are being carried away from us by the expansion of the space between us and them, and the farther away they are, the faster they recede, not because they are moving faster through space, but because there is more expanding space between us and them. At a certain distance, the recession speed, driven purely by the expansion of space, reaches the speed of light. Beyond that distance, the recession is faster than light. This does not violate any physical law, because nothing is moving through space faster than light. Space itself is simply growing faster than light can cross it, and the consequence of this is something that should stop you, something that should make the night sky feel different the next time you look at it. There are galaxies in the observable universe, galaxies whose light is currently reaching your eye, that are already receding from you faster than light. Their light left them long ago, when they were close enough for the light to begin its journey toward you. But since then, the space between you and them has grown so much that those galaxies are now beyond a boundary called the cosmic horizon, a boundary beyond which no new light they emit will ever reach you. The light you are receiving from them now is the last light you will ever receive. Every photon that leaves those galaxies from this moment forward will be carried away from you by the expansion of space faster than it can travel toward you. It will never arrive. The universe is already, right now, in the process of removing parts of itself from your view, not dramatically, not with any announcement, just quietly, continuously, as the expansion carries distant galaxies beyond the horizon of what can ever be known. The universe is editing itself, and the direction of the edit is always the same, less visible, less reachable, less available. But the night sky does not show you this. The night sky shows you the light that is still arriving, the messages that were sent long enough ago to have made the journey. It does not show you the silence that is growing at the edges, the galaxies that have already crossed the horizon, the regions of space that are already beyond the reach of any signal you could ever send or receive. The night sky is the last generous illusion of a universe that is, in its deepest structure and its long-term trajectory, becoming less generous with every passing moment. To feel the true scale of this, you have to try to hold two things in your mind at once. The first is the image of the night sky as you know it, bright, populated, seemingly close, seemingly permanent. The second is the reality beneath that image, a universe that is almost entirely empty, structured around enormous voids, expanding in a way that is continuously increasing the distance between unbound objects, and already in the process of placing parts of itself permanently beyond the reach of observation. These two images do not fit together easily. They resist each other, and that resistance is not a failure of understanding. It is the beginning of it. The universe looks full because you are standing inside one of the rare, bright places. You are on a planet orbiting a star in a galaxy that is part of a cluster, that is part of a filament of the cosmic web. You are, by cosmic standards, in one of the most crowded neighborhoods the universe has to offer. And even here, even in this relatively dense region, the distances between stars are so vast that if the sun were the size of a grain of sand, the nearest star would be another grain of sand several kilometers away, with nothing but empty space between them. Even in the crowded places, the universe is almost entirely empty. Step back from the filament, step back from the cluster, step back from the galaxy. Step back until the filament itself is just a faint thread in the larger structure, and the voids around it are the dominant feature of the view. Now you are seeing the universe more honestly. Now the emptiness is not the background, it is the foreground, it is the main character. The bright threads are the anomaly, the dark is the rule, and the dark is not static, the dark is growing. Not because the voids are expanding in the sense of matter moving outward from their centers, though that is also happening to some degree. The dark is growing because the universe itself is expanding, and as it expands, the voids grow proportionally larger, the filaments grow proportionally thinner, and the distances between the bright nodes of the cosmic web grow proportionally greater. The universe is not simply large, it is becoming larger, and the rate at which it is becoming larger is not slowing down. It is, as far as current understanding can determine, accelerating. This is where the story changes. This is where the emptiness stops being merely a feature of the present universe and becomes a description of the future. Because if the expansion is accelerating, if the rate at which space is growing is increasing rather than decreasing, then the future of the universe is not a gradual settling into some stable configuration. It is a future of increasing separation, increasing isolation, increasing distance between everything that is not already bound together by gravity. It is a future where the universe becomes, with every passing era, less connected, less visible, less knowable. The force or the effect or the property of space, whatever it ultimately turns out to be, that is driving this acceleration has a name: dark energy. It is called dark not because it is sinister, though the implications are, but because it does not interact with light in any way we can detect. It does not glow, it does not absorb, it does not scatter. It is invisible to every instrument we have ever built, detectable only through its effect on the expansion of space itself. And its effect is this: it is pushing the future of the universe toward a condition of irreversible isolation. Dark energy is not a small correction to the story of the universe. It is, by current estimates, the dominant component of the universe's total energy content. More than 2/3 of everything the universe is made of, in terms of energy, is this invisible, unnamed, poorly understood thing that is making space grow faster and faster. The matter you can see, the stars and galaxies and gas clouds, the entire luminous universe, accounts for only a small fraction of what is actually there. And even that fraction is dwarfed by the dark matter, the invisible gravitational scaffolding that holds the luminous structures together, which itself accounts for a much larger share than all the visible matter combined. The universe you can see is not the universe. It is a thin, bright, temporary decoration on the surface of something far larger, far darker, and far less understood. And the thing that is driving the future of that larger, darker universe is something that, as of this moment, no one fully understands. Dark energy is a name for an observation. It is a label placed on a mystery, and the mystery is this: space is not neutral. Space is not simply the absence of matter. Space has a property or contains something that causes it to expand at an accelerating rate, and that acceleration is carrying the universe toward a future that is, in almost every meaningful sense, emptier than the present. This is the contradiction the night sky hides most completely. It looks like a place of abundance. It looks like a place where things are happening, where light is being made, where structure is forming, where the universe is in some sense building itself. And in the present moment, in the current era of cosmic history, that is partially true. Stars are still forming. Galaxies are still colliding and merging and producing new generations of stars. The universe is still in certain bright corners, creative and active and luminous. But the direction of travel is not toward more of this. The direction of travel, written into the expansion rate and the properties of dark energy and the long-term logic of entropy, is toward less light, less structure, less connection, less visibility. The universe is not building toward something. It is, in the deepest sense, winding down, not quickly, not dramatically, but irreversibly. And the scale of the winding down is so vast and the timescales involved are so incomprehensible that the human mind can barely hold the shape of what is coming. But before we follow that trajectory into the deep future, there is something else the present universe is hiding. Something that makes the emptiness even stranger, even more fundamental, even more unsettling than the voids and the expansion alone can suggest. Because the matter you can see, the matter that makes up the stars and the galaxies and the filaments of the cosmic web, that matter is not the only matter. It is not even most of the matter. There is another kind, invisible, undetectable by any direct means, present everywhere in quantities that dwarf the luminous matter, and it is this invisible matter that is, in a very real sense, the true skeleton of the universe. The luminous matter is just what happens to glow where the skeleton is dense enough. The skeleton has a name too, dark matter, and its existence, inferred from the behavior of galaxies and clusters and the large-scale structure of the cosmos, tells you something profound about the nature of what you are looking at when you look at the night sky. You are not seeing the universe. You are seeing the parts of the universe that happen to emit light. The rest, the majority, the dominant gravitational presence, is invisible to you. It is there, shaping everything, holding everything together, determining the structure of the cosmic web and the fate of every galaxy within it, and you cannot see it. You can only see its shadow, cast in the motion of the things that do glow. The universe is not what it looks like. It never was. The night sky is a beautiful, ancient, deeply misleading portrait of a reality that is mostly dark, mostly empty, mostly invisible, and mostly moving away from you faster than you can follow. And the further you look into it, the more clearly you begin to see not abundance but the architecture of an absence so vast and so fundamental that it changes the meaning of everything that appears to be there. This is where the journey begins, not with the stars, not with the light, but with the growing understanding that the light is the exception, the emptiness is the rule, and the rule is not standing still. It is accelerating, it is deepening, it is carrying the universe with every passing moment, further into a condition that has no name in any human language, because no human has ever experienced anything remotely like it, and no human ever will. But the universe is heading there regardless, and the direction it is heading is not toward fullness or warmth or connection. It is heading towards something that looks, from every angle we can examine, like the slow, irreversible, and absolute victory of the void. There is a way of looking at the cosmic web that makes it feel almost biological. The filaments connecting galaxy clusters resemble, at certain scales and in certain visualizations, the structure of a nervous system, or the branching of roots beneath soil, or the network of vessels carrying something vital through a living body. It is tempting to read intention into it, to see the universe as something organized, something purposeful, something that has arranged itself the way a living thing arranges itself, with structure serving function and form following some deeper logic. But the resemblance is superficial, and the comfort it offers is false. The cosmic web did not form because the universe was trying to build something. It formed because gravity is indifferent and patient, and given enough time and the right initial conditions, indifferent patience produces structure that looks, to eyes evolved to find patterns, like intention. The filaments are not pathways. The nodes are not centers of anything meaningful. The voids are not spaces waiting to be filled. The web is not a network in any functional sense. It is the residue of a process that had no goal, no direction, and no awareness of what it was producing. And the structure it produced, for all its visual complexity, is built almost entirely around emptiness. The filaments are thin. The nodes are dense but small relative to the distances between them. The voids are enormous. If you were to assign a color to matter and a color to empty space and paint the observable universe at its true proportions, the result would be almost entirely the color of nothing, with faint, hair-thin lines of something crossing the dark at intervals so large that the lines would be nearly invisible. The universe, painted honestly, would look almost blank. This is not a metaphor. This is the actual geometry of the cosmos at its largest observable scales. The structures that feel significant, the galaxies, the clusters, the superclusters, the filaments themselves, are, in terms of the volume they occupy, negligible. They are the rounding error in a calculation whose dominant term is absence. And the absence is not uniform. It is organized. It has shape. The voids are not random holes punched through a solid medium. They are coherent regions, some of them nearly spherical, some elongated, some connected to other voids through narrow tunnels where the density is slightly higher than the void interior, but still far below the density of any filament. The universe has an architecture of emptiness, and that architecture is as real and as structured as the architecture of the matter that defines its edges. To understand why this matters, you have to think about what the voids are doing to the matter around them. Because the voids are not passive. They are not simply regions where gravity failed to gather matter. They are regions where the expansion of the universe, combined with the initial underdensity of those regions, has actively driven matter outward toward the surrounding filaments. The voids are, in a sense, evacuating themselves. The slight underdensity that existed in those regions in the early universe meant that the gravitational pull from outside was stronger than the gravitational pull from within, and over billions of years, matter has been slowly drained from the void interiors toward the filaments and nodes at their edges. The voids are growing, not just because the universe is expanding and carrying everything apart, but because the internal dynamics of the large-scale structure are continuously moving matter away from the void centers and toward the surrounding web. The voids are becoming emptier as the filaments become denser, and the universe is becoming more extreme in its contrasts, more concentrated in the bright places and more evacuated in the dark ones, even as the overall expansion carries everything apart. But here is where the story of dark matter enters, and it enters not as a solution, but as a deepening of the mystery. Because the process that built the cosmic web, the gravitational amplification of tiny initial density fluctuations into the large-scale structure we observe today, could not have happened with ordinary matter alone. The ordinary matter, the protons and neutrons and electrons that make up everything you have ever touched or seen, was, in the early universe, coupled to radiation. It was locked in a hot, dense plasma, where the pressure of light prevented it from collapsing under gravity. It could not begin to form structures until the universe had cooled enough for matter and radiation to decouple, an event that happened roughly 380,000 years after the beginning. 380,000 years sounds like a long time. In the context of the universe's current age of nearly 14 billion years, it is a brief opening chapter. But it is long enough to matter because the structures we observe today, the filaments and voids and clusters of the cosmic web, required much more time to form than the ordinary matter alone could have produced starting from that late decoupling. The ordinary matter, starting its gravitational collapse at 380,000 years, would not have had time to produce the structures we see. The universe would look different, smoother, less organized, less extreme in its contrasts. The fact that the universe looks the way it does, with the degree of structure and the scale of voids that we observe, requires that something else was already collapsing under gravity long before the ordinary matter was free to do so, something that was not coupled to radiation, something that could begin forming gravitational wells in the early universe, wells deep enough that when the ordinary matter finally decoupled from radiation, it fell into those pre-existing wells and began to form the structures we see. That something is dark matter. Dark matter does not interact with light. It does not emit it, absorb it, or scatter it. It passes through ordinary matter almost without interaction. It is present everywhere in the universe in quantities that, by current estimates, outweigh ordinary matter by roughly 5 to 1. For every kilogram of ordinary matter in the universe, there are approximately 5 kilograms of dark matter, and yet you cannot see it. You cannot touch it. You cannot detect it with any instrument that relies on electromagnetic interaction, which is to say almost every instrument ever built. You can only see its gravitational effects. The way galaxies rotate faster at their edges than they should if only the visible matter were present. The way galaxy clusters bend light from objects behind them more strongly than their visible mass can account for. The way the large-scale structure of the universe matches the predictions of models that include dark matter and fails to match the predictions of models that do not. Dark matter is not a hypothesis born of desperation. It is a conclusion forced by observation, by the consistent failure of visible matter alone to explain the behavior of the universe at every scale above the individual star. And what dark matter tells you, when you sit with its implications, is that the universe you can see is not the universe. The luminous matter, The stars and gas and dust that make up every galaxy you have ever observed is a thin, glowing film on the surface of a much larger, much more massive, completely invisible structure. Every galaxy is embedded in a halo of dark matter, far larger than the galaxy itself. Every cluster of galaxies is embedded in an even larger dark matter halo. The filaments of the cosmic web are, in their true form, filaments of dark matter, with the luminous matter concentrated along their cores like frost forming on the edges of something cold and invisible. The universe is not what you see. The universe is mostly something you cannot see, and the something you cannot see is what determines the shape and fate of everything you can. The visible universe is the shadow of the invisible one. The light is the trace. The dark matter is the substance. And the substance is, by its nature, unknowable through any direct observation available to us. We know it is there. We know roughly how much of it there is. We know the broad outlines of how it behaves. But we do not know what it is. We do not know what particle or field or phenomenon it corresponds to. It is the dominant form of matter in the universe, and it is, in the most literal sense, a mystery. This should unsettle you, not because dark matter is dangerous or threatening in any direct sense, but because it means that the universe has been hiding its own nature from you. The thing that built the cosmic web, the thing that made galaxies possible, the thing that holds the luminous structures together against the expansion of space, is something you cannot see, cannot touch, cannot identify, and cannot explain. The universe is not transparent. It is not showing you what it is made of. It is showing you only the parts that happen to glow, and those parts are the minority, the surface, the decoration on a structure whose true nature remains, for now, beyond reach. But it goes deeper, because even the dark matter, for all its invisibility and mystery, is at least something. It has mass. It has gravitational influence. It participates in the universe in a way that can be measured, even if not directly observed. The dark energy is something else entirely. The dark energy is not matter of any kind. It is not a particle or a field in the conventional sense, or if it is, we have no way of knowing what kind. It is, as far as current understanding can determine, a property of space itself, a tendency of empty space to contain energy, to push outward, to resist compression, to drive expansion. And it is this property of space, this energy of the vacuum, that is responsible for the most disturbing fact about the future of the universe. The expansion of the universe is not slowing down. For most of the universe's history, the expectation was that it would. Gravity, acting on all the matter in the universe, should have been gradually decelerating the expansion, pulling everything back toward itself, slowing the outward rush of space. The question was not whether the expansion would slow, but whether it would slow enough to eventually reverse, to bring the universe back together in a final collapse, or whether it would slow but never stop, allowing the universe to expand forever, but at a decreasing rate. The answer, discovered through observations of distant supernovae in the late 20th century, was neither of those. The expansion is not slowing, it is accelerating. The universe is not being pulled back together. It is being pushed apart, faster and faster, by something that acts in opposition to gravity on the largest scales. And that something, the dark energy, is not diminishing as the universe expands. It is, as far as we can determine, constant. A fixed energy density of empty space that does not dilute as space grows, because it is a property of space itself, not a substance within it. This is the point where the story of the universe changes from a story about what exists to a story about what is being lost. Because if dark energy is constant, and if the expansion is therefore accelerating without limit, then the future of the universe is not a future of gradual settling. It is a future of runaway separation. The galaxies that are currently beyond the cosmic horizon will remain beyond it forever. The galaxies that are currently just inside the horizon will eventually cross it and disappear. The observable universe, the region from which we can receive light, will not grow larger over time. It will shrink. The universe will become, from the perspective of any observer within it, progressively smaller in terms of what can be seen and known, even as it becomes physically larger in terms of the volume of space it contains. Think about what this means. The universe is expanding. The volume of space is growing, but the portion of that space that is accessible to any given observer, the portion from which light can still reach that observer, is shrinking. The universe is becoming simultaneously larger and less available. More space, less of it reachable. More volume, less of it visible. The universe is growing in a direction that makes it less knowable, not more. And the galaxies that are disappearing beyond the horizon are not disappearing in any dramatic sense. They are not exploding or collapsing or ceasing to exist. They are simply being carried away by the expansion of space until the distance between them and us becomes so great and the recession so fast that no light they emit can ever cross that distance. They will continue to exist, presumably, on the other side of the horizon. Stars will continue to burn in them. Planets will continue to orbit. Whatever processes are occurring in those galaxies will continue to occur. But none of it will ever be visible to us. None of it will ever be knowable to us. It will happen in a region of the universe that has become, for all practical and theoretical purposes, a separate universe, a place that shares the same physical laws, the same origin, the same history up to a certain point, but that is now permanently cut off from any causal connection with us. The cosmic horizon is not a wall. It is not a surface you could approach and touch. It is a limit defined by the relationship between the speed of light and the rate of expansion of space. It is a boundary of causality, a line beyond which events can occur without ever having any effect on anything on this side. And it is moving, not outward, allowing us to see more, but in a sense inward, as the accelerating expansion carries more and more of the universe beyond the point where its light can reach us. There is something deeply strange about this. The universe is not hiding things from us by placing them behind obstacles. It is hiding things from us by expanding the space between us and them until the space itself becomes the obstacle. The barrier is not matter. It is not a wall of any kind. It is the geometry of an expanding universe. The simple fact that space is growing faster than light can cross it, and that fact is sufficient to make entire regions of the cosmos permanently inaccessible. The universe is using its own expansion as a mechanism of concealment, and the concealment is irreversible. Once a galaxy crosses the cosmic horizon, it is gone from our universe in every meaningful sense. The light it emits from that moment forward will never reach us. The events that occur within it will never influence us. The information it contains will never be available to us. It is not destroyed. It is not dead. It is simply unreachable, permanently and completely, by any means that physics allows. And the number of galaxies in this condition is already enormous and growing with every passing moment, but it gets worse. Because the galaxies that are currently visible to us, the ones whose light is still arriving, are not going to remain visible indefinitely. As the expansion continues and accelerates, the light from progressively closer galaxies will be redshifted to longer and longer wavelengths. The expansion of space stretches the wavelength of light as it travels, shifting it toward the red end of the spectrum and eventually beyond it, into infrared, then microwave, then radio frequencies too long to detect with any plausible instrument. The galaxy does not disappear suddenly. It fades, it reddens, it dims, and eventually, the light it is emitting becomes so stretched by the expansion of the space it is crossing that it arrives with almost no energy, at wavelengths so long they carry almost no information, and the galaxy effectively vanishes from observation not because it has ceased to exist, but because the universe has stretched its signal into silence. This is the mechanism by which the universe erases its own history from the view of any observer within it, not through destruction, not through catastrophe, through the quiet, continuous, irreversible stretching of light into wavelengths too long to carry meaning. The universe is not burning its records. It is simply expanding until the records become unreadable, and the records that are being erased are not trivial. They are the entire history of the universe beyond our local gravitational neighborhood. Every galaxy that fades beyond the horizon takes with it the information about its stars, its planets, its history, its future. Every region of space that becomes unreachable takes with it whatever has happened and whatever will happen within it. The universe is not losing matter. It is losing accessibility. It is losing the ability of any part of itself to know what any other sufficiently distant part is doing. It is losing its own coherence as an observable, knowable whole. There is a concept in physics called the observable universe, the sphere of space centered on any given observer from which light has had time to reach that observer since the beginning of the universe. The observable universe is not the whole universe. It is the portion of the universe that is, in principle, visible from a given location, and the size of the observable universe is not fixed. It changes as the universe ages, as more light has time to arrive, but also as the expansion carries distant sources beyond the horizon. The net effect, in an accelerating universe, is that the observable universe will eventually stop growing and begin to shrink, as the rate at which sources are lost to the horizon exceeds the rate at which new sources become visible. At some point in the far future, the observable universe will contain only the galaxies that are gravitationally bound to our local group. Everything else will have receded beyond the horizon. The night sky of that future era will not look like our night sky. It will be darker. The distant galaxies that currently populate the deep field images of our telescopes will be gone, not destroyed, but invisible, unreachable, beyond the horizon of what can ever be known. The universe will still exist in its full extent, but from the perspective of any observer within it, it will appear to consist only of the local gravitational island, surrounded by an emptiness that extends in every direction without limit and without content. This is not a distant hypothetical. It is the logical consequence of the physics we currently understand, extrapolated forward in time. The acceleration of the expansion is not a temporary phase. There is no known mechanism by which it would reverse or cease. The dark energy, whatever it is, shows no sign of diminishing. And if it does not diminish, the future it implies is one of progressive, irreversible isolation, in which the universe becomes, from the inside, a collection of separate islands, each surrounded by an expanding void that grows larger and emptier with every passing era. The local group of galaxies, the collection of gravitationally bound galaxies that includes the Milky Way and the Andromeda Galaxy and several dozen smaller companions, will remain together. Gravity is strong enough at these scales to hold the group against the expansion. The Milky Way and Andromeda are, in fact, on a collision course expected to merge in several billion years into a single large elliptical galaxy. The local group will eventually coalesce into a single massive structure, a merged remnant of all the galaxies currently bound to it, surrounded by the expanding void that will have swallowed everything else. That merged remnant will be an island, a gravitational island in a sea of expanding emptiness. The nearest other island, the nearest other gravitational group, will be receding away from it at speeds that make any contact impossible. The universe will have sorted itself into isolated pockets of matter, each pocket surrounded by a void that grows larger with every passing moment, each pocket unable to communicate with or even observe any other pocket. The universe will have fragmented, not through any violent process, but through the simple, patient, relentless action of expansion on the space between things that are not bound together. And within each island, the story does not end with isolation. It continues into a future that is, if anything, more unsettling than the isolation itself. Because the matter within each island is not permanent, the stars within each island are not eternal. The energy that drives the light and heat and activity of each island is finite, and it is being spent, and it will eventually run out. The universe is not only becoming more isolated, it is becoming more exhausted. This is where entropy enters the story, and entropy is perhaps the most quietly terrifying concept in all of physics, not because it is violent or sudden, but because it is inevitable and universal and admits of no exceptions. Entropy is, in its simplest description, the tendency of systems to move from ordered, structured, energy-concentrated states toward disordered, diffuse, energy-spread states. It is the reason a hot cup of coffee cools in a cold room and never spontaneously heats itself back up. It is the reason a broken glass does not reassemble itself. It is the reason that every process in the universe that involves energy exchange moves in one direction, from concentration to diffusion, from structure to disorder, from difference to sameness. In the context of the universe as a whole, entropy means that the energy concentrated in stars, in the temperature differences between hot stellar surfaces and cold space, in the chemical and gravitational potential of matter, is continuously being degraded. Stars burn their nuclear fuel and radiate the energy as light and heat into the surrounding space. That energy spreads out, dilutes, redshifts as the universe expands, and becomes less and less available for doing anything useful. The universe is, in a thermodynamic sense, running down. The concentrated energy of its early state is being continuously converted into the diffuse, low-grade warmth of an aging cosmos. The stars are the most visible expression of this process. Each star is a temporary concentration of energy, a place where gravity has compressed matter until nuclear fusion ignites and begins converting mass into radiation. The radiation pours out into space, carrying energy away from the star, and the star slowly depletes its fuel. The most massive stars burn brightest and die fastest in millions of years. Stars like the Sun burn for billions of years. The smallest, dimmest stars, the red dwarfs, burn so slowly and so efficiently that they will persist for trillions of years, long after the Sun has died and the Earth has been consumed. But even the red dwarfs will eventually exhaust their fuel. Even the longest-lived stars will eventually cool and fade, leaving behind dense remnants, white dwarfs, neutron stars, black holes, objects that no longer generate energy through fusion but simply exist, cooling slowly, radiating whatever residual heat they have into the surrounding space. The universe will not always be a place where stars are burning. There will come an era, unimaginably far in the future, when the last star has exhausted its fuel and gone dark, and the universe will contain no more stellar light, no more fusion, no more of the process that has, for most of cosmic history, been the primary source of light and heat and the energy that makes complex chemistry possible. This era is called, in the language of cosmology, the degenerate era, the long age after the last stars have died, when the universe is populated primarily by the cold remnants of stellar evolution. White dwarfs cooling toward absolute zero over timescales that dwarf the current age of the universe by factors that are difficult to express. Neutron stars, dense and dark, orbiting each other in systems that will eventually decay through the emission of gravitational waves. Black holes, the most extreme remnants of stellar death, consuming whatever matter falls within their reach, and slowly, over timescales so vast, they make the current age of the universe look like an instant, evaporating through a quantum process that releases their mass as a trickle of low-energy radiation. The black holes will be the last structures. After the stars are gone, after the white dwarfs have cooled, after the neutron stars have decayed, the black holes will remain, growing slowly as they consume whatever matter comes within their gravitational reach, and shrinking slowly as they evaporate through the quantum process that bleeds their mass away as radiation. The largest black holes, the supermassive ones at the centers of galaxies, will take the longest to evaporate. The timescales involved are numbers so large that writing them out in standard notation requires exponents of exponents, numbers that have no intuitive meaning, numbers that make the current age of the universe, nearly 14 billion years, look like the first fraction of a second of a journey that has barely begun. But even the black holes will eventually be gone. Even the most massive, most long-lived black holes will eventually complete their evaporation, releasing their last energy as a final burst of low-grade radiation and leaving behind nothing, not even a remnant, just the space that was once inside them, now empty, now indistinguishable from the surrounding void. The universe will have consumed itself, not through collapse or explosion, but through the slow, patient, thermodynamically inevitable process of converting every concentration of energy into diffuse radiation that spreads through an ever-expanding space and becomes, with every passing moment, less energetic, less structured, less capable of doing anything at all. This is the heat death. Not a death by heat, but a death into heat, into the uniform, diffuse, low-temperature radiation of a universe that has spent all its concentrated energy and has nothing left to spend. A universe in which the temperature everywhere is the same, or as close to the same as makes no difference, because all the temperature differences that once drove processes, that once powered stars and chemistry, and whatever else the universe has produced, have been smoothed away by the relentless action of entropy. A universe in which nothing happens not because anything has been destroyed, but because there is no longer any difference between one place and another, no gradient to drive any process, no concentration of energy to power any change. The heat death is not a moment, it is a condition that the universe approaches asymptotically, getting closer and closer without ever quite arriving, because the approach itself takes infinite time. But the approach is real, and the direction is fixed, and there is nothing in the known physics of the universe that would reverse it. The universe is moving toward a state of maximum entropy, minimum structure, minimum difference, minimum possibility. It is moving toward a condition that is, in every meaningful sense, the opposite of what it is now. And the most disturbing thing about this trajectory is not the destination, it is the direction. The universe is not moving towards something. It is moving away from something. It is moving away from the concentrated, structured, energetic, luminous state it was in at its beginning, and toward a state that is, by comparison, indistinguishable from nothing. Not nothing in the sense of non-existence, but nothing in the sense of no difference, no structure, no process, no event. A universe that continues to exist, but in which nothing ever happens again, because there is no longer any reason for anything to happen. The silence at the end of the universe is not the silence of a room after the music stops. It is the silence of a space so large and so empty and so uniform that the concept of music, of any organized, structured, meaningful pattern, has become permanently impossible. It is the silence of a universe that has forgotten, if forgetting is even a meaningful concept in this context, everything it ever was. But we are getting ahead of ourselves. The heat death is unimaginably far away. The era of stars is still ongoing. The universe is still in its current chapter producing light and structure and the conditions for complexity. The story of the present universe is not yet the story of the end. It is the story of the middle, of a cosmos that is still active, still luminous, still capable of producing the kind of complexity that, on at least one small planet, orbiting one ordinary star in one unremarkable galaxy, has produced something capable of looking up at the night sky and asking what it is looking at. But the middle is not the whole story, and the direction from the middle toward the end is not ambiguous. The universe is not cycling. It is not oscillating. It is not building toward a new beginning. It is moving, in one direction, toward a state of increasing emptiness, increasing isolation, increasing entropy, and decreasing possibility. The arrow of time points in one direction, and the universe is following it, and the destination it points toward is not a place you would choose to go. The cosmic web, for all its beauty and complexity, is a temporary structure. The filaments that connect galaxy clusters will not persist forever. As the expansion continues and accelerates, the filaments will be stretched thinner, the connections between clusters will weaken, and eventually the expansion will overcome even the gravitational bonds that hold the largest structures together. The superclusters will dissolve, the filaments will break. The cosmic web will unravel, not suddenly, but over timescales that make the current age of the universe seem brief, until what remains is not a web but a collection of isolated islands, each one a gravitational remnant of what was once a connected structure, each one surrounded by an expanding void that grows larger and emptier with every passing era. The universe is not building, it is dissolving, slowly, patiently, irreversibly. The structures that exist today are the most complex the universe will ever produce, or close to it. The future holds not greater complexity but greater simplicity, not more connection but more isolation, not more light but more darkness. The universe has already passed, or is passing, through its period of greatest richness, and what lies ahead is a long, slow, uninterrupted decline toward a condition that has no name in any language built by creatures who have only ever known the current era. And yet the universe will continue. That is perhaps the strangest part. It will not end. It will not collapse. It will not cease to exist. It will simply continue, expanding, cooling, emptying, for a duration that has no meaningful upper limit. The universe will go on, becoming larger and colder and darker and emptier, and the things within it will become fewer and simpler and more isolated, until the last black hole evaporates and the last photon redshifts to a wavelength longer than the observable universe, and what remains is a space so vast and so empty and so cold that the word universe seems almost ironic. A universe with almost nothing in it, a universe that is, in every sense that matters, alone. You look deeper into this future, this vast and growing emptiness, and begin to realize that the silence is not just the absence of sound, it is the absence of meaning. Meaning is structure. Meaning is contrast. Meaning is the difference between one thing and another. If the universe approaches a state where those differences vanish, where every particle and photon is equally cold, dim, and distant, then meaning itself slips away. Imagine standing on a dark shore and watching waves approach one by one, each wave bringing fragments of distant shores, stories, encounters. Each wave carries light, information, connection, but now the waves grow fewer. They lose their form. They fade into a slow swell that never reaches you. The shores are receding beyond any horizon your mind can grasp. The stories are left unheard, and you are left with the sound of absence, the endless calm of a void that swallows every echo. The scale of cosmic emptiness dwarfs any human experience of loneliness or isolation. Yet here, in this geometry of absence, you find a reflection of something deeply unsettling about existence itself. The experience of being part of a system continuously separating from itself, becoming less accessible to its own complexity, dimming like a candle whose flame is stretched thin by an unrelenting wind. You are standing inside a universe that is already leaving itself behind. The arms of galaxies you see tonight, glowing faintly amid the black, are already in the process of receding. Their light that reaches you now is like a ghost's whisper from a banquet that is drawing to an end. New light they emit will come never. The universe's expansion is a river pulling everything downstream toward a destination where the banks fall away and the waters open into an endless void. But even this image betrays the evidence. There is no bank, no end, no boundary. The universe has no edge, no center, no wall you can reach. The expanding emptiness is not contained. It is unbounded. It grows without limit, not in space. It is space, but in the distances that separate every point from every other. Every island of matter is isolated upon a sea that cannot be crossed, no matter what vessels are built or what messages are sent. And this leads to something more disturbing still. You may imagine that the universe's increasing scale would bring new richness, new regions to explore, new galaxies to encounter, new light to discover. But the reality is the opposite. The accelerating expansion makes the future horizon a point of no return. The universe is pruning itself, removing from itself the possibility of ever again learning about or interacting with these regions. The horizon is a one-way screen. Beyond it, events unfold eternally, but they cannot and will not influence your reality. No signal, no information, no light can cross back over the threshold. You remain forever trapped inside your observational bubble, shrinking as the void beyond grows. The universe is not shy with its secrets, it is forgetting that it ever heard the questions. You may wonder about the consequences for any civilization that reaches this future. What happens to beings inside gravitational islands as they watch the night sky grow darker and quieter, the distance to every unbound galaxy increasing until those galaxies vanish from sight? They become prisoners not of walls or chains, but of distance itself, a distance that grows relentlessly, creating isolation as absolute as any prison. The great cosmic connection that once linked all matter and energy into a single observable whole will be fractured into disconnected patches, each unaware of the other's existence, each unable to send or receive even the simplest message. The universe, which once seemed to promise infinite discovery, now promises nothing but islands separated by an eternal sea of nothing. And the isolation is complete. It is not possible to bridge the gaps. The gaps are not geographic in the usual sense. They are metric. They are expanding space. No vehicle, no signal, no construction can overcome the stretching fabric of the cosmos between these remaining islands. Light itself cannot travel fast enough to keep these connections alive. The universe is becoming irrevocably inaccessible to itself. And it goes deeper, because the islands themselves are not eternal in any meaningful sense. They are bound structures, shielded from the expansion by their own gravity. But gravity has limits. Gravity holds what can be held, but gravity cannot create new stars from nothing. It cannot stop the depletion of fuel. It cannot revive what has faded. Inside these islands, stars age and burn out. Gas clouds collapse into stars, but only until the gas runs out. The cycles of stellar birth and death become ever slower because the fuel reservoir shrinks, because entropy forbids infinite recycling. Eventually, star formation ceases. The universe becomes, inside these islands, a more static and colder place. The light grows dimmer, the warmth fades, the activity slows. The rich tapestry of a cosmos alive with processes contracts into a night without dawn. Even these havens of matter become quiet. Thermodynamics is merciless. It pushes every process toward conclusion, every system toward rest, every difference toward uniformity. And this leads to a final disquieting question. What happens when contrast itself disappears? When the universe is a spatially expanding sea of near-perfect uniformity, where distinctions between hot and cold, bright and dark, dense and rarefied vanish, when temperature equalizes and energy gradients flatten, when every point becomes indistinguishable from every other point, in such a universe, change itself becomes impossible. Motion requires difference. Heat flow requires difference. Processes require differences in energy and concentration. Without these, the universe is frozen not in time, but in meaning. Events cease to occur. Time may still tick forward, but time without change is time without narrative, without history, without anything to mark its passage. The universe drifts into a silence that is absolute. It is not the silence of nothing happening for a moment. It is the silence of nothing ever happening again. The silence of infinite duration, devoid of new events, new connections, new discoveries. The silence of a cosmos scaled beyond comprehension, emptied not by destruction but by abandonment. A universe that ghosts on, endlessly expanding, endlessly cooling, endlessly emptying. And the collective terror of this future is not that the universe stops existing, but that it exists as something that can never again be known to itself, that its parts will never again see or touch or influence each other. That memory fades as accessible space shrinks, and that the stars, those ancient signals of presence and vitality, fade beyond detectability, like dying embers swallowed by a vast and eternal night. You gaze into this darkened future and confront what might be the deepest unease of all, a cosmos that does not end with a blaze, but a slow, inexorable fading, that does not rise and then fall, but unwinds its own complexity into uniformity. That does not conclude with meaning affirmed, but with meaning lost, with the evaporation of contrast and connection, until almost nothing remains close enough to be seen, touched, remembered, or known. What is left in the vastness beyond your reach? Does anything remain? The answer, as far as evidence and theory can guide, is yes. But it is a yes that offers no consolation. Beyond every horizon, beyond every shadow cast by expanding space, there may be endless regions where events unfold out of causal contact with us, where stars shine, planets orbit, civilizations may rise and fall, but these places are effectively severed from the thread of the cosmos you inhabit. You are left with islands of substance surrounded by endless seas of darkness and silence growing steadily between dimensions of space that are less spaces and more absences, each retreating from the other into unreachable isolation. The universe fragments into a great loneliness, a fracturing of itself into pieces that no longer form a coherent whole. This fracturing is not sudden. It is a patient process, without drama, but without reversal. It unfolds over eras so long your mind rebels at naming them. Yet the direction is certain, a future where distance triumphs, light disappears, energy diffuses beyond utility, and the universe, which once seemed full and alive, becomes a vast emptiness that no eyes can pierce, no voices can bridge. And so you find yourself, unfinished and unavoidable, inside a story with no final act, only an endless fading. The universe is not moving toward the fiery collapse you imagined, nor even a sudden deep freeze. It is dissolving in slow motion, fading into a darkness that is less an event than an eternal condition. The vastness beyond our reach is not a horizon to cross, but a boundary that grows in all directions with time, a cosmic silence spreading until it occupies all there is. And you are there, watching it grow. There is no escape from this. No witness can leave it. No signal can traverse it. No structure can resist it indefinitely. The universe's future is not a climax. It is a long, quiet cessation, not an ending marked with fire or thunder, but with the gradual extinguishing of all that once burned. And in this, the emptiness is not absence. It is presence, the presence of a slowly encroaching void, the dominant force shaping reality, the ultimate state toward which all things tend. The emptiness is not a feature, it is the destiny. You stand inside this universe now and always, part of a vast system continuously unraveling itself into isolated fragments of matter, separated by an ever-growing expanse of silence. And you understand that the grandest terror of cosmic existence is not that the universe will die with a bang, but that it may never stop growing larger, colder, darker, emptier, until almost nothing remains close enough to be seen, touched, remembered, or known. Beyond the universe you perceive, a universe recedes, an expanse that, though infinite in some interpretations, is effectively shrinking in what can be reached. You are not just observers of a cosmic spectacle. You are participants in an unraveling story where expansion is erasure, distance is death, and light is a fading memory. And so, surrounded by the night's deceiving beauty, you find yourself intertwined with a silent fate, a cosmos not so much alive as unraveling, not so much growing as retreating, expanding not into life, but into an ever-deepening, eternal isolation. There is a particular quality to the darkness between galaxies that no description fully captures. It is not the darkness of a room with the lights off, where walls exist just beyond your reach and the familiar geometry of a known space surrounds you. It is not the darkness of a cave, where the rock is close and the air is still, and the absence of light is a local condition that ends somewhere ahead. The darkness between galaxies is a darkness of scale, a darkness produced not by the absence of a light source nearby, but by the presence of distances so enormous that even the combined light of hundreds of billions of stars, burning across an entire galaxy, arrives as nothing more than a faint smudge, a barely perceptible brightening of the void, a whisper of photons that have traveled for millions of years, and arrive carrying almost nothing of the fire that produced them. This is the intergalactic medium, the space between galaxies. It is not a perfect vacuum because perfect vacuums may not exist anywhere in the universe, but it is as close to nothing as anything in the observable cosmos comes. The density of matter in the intergalactic medium is so low that a cubic meter of it contains on average less than a single atom. In some regions, far from any filament of the cosmic web, the density drops even below that. You could travel through the intergalactic medium for millions of light years and encounter almost nothing. No dust, no gas clouds, no stray particles of any significance, just the faint, cold, nearly uniform glow of the cosmic microwave background, the ancient afterglow of the universe's early heat, now stretched by billions of years of expansion into microwave radiation so cold, it sits just a few degrees above absolute zero. The cosmic microwave background is itself a record of the universe's past, a snapshot of the moment, roughly 380,000 years after the beginning, when the universe had cooled enough for electrons and protons to combine into neutral hydrogen atoms, allowing light to travel freely for the first time. Before that moment, the universe was opaque, a hot, dense plasma through which light could not pass. After that moment, the universe became transparent, and the light that was released at that transition has been traveling ever since, cooling and redshifting as the universe expanded. Until today, it fills all of space as a nearly uniform background of microwave radiation. Nearly uniform, not perfectly uniform. The tiny variations in the temperature of the cosmic microwave background, fluctuations of roughly 1 part in 100,000, are the imprint of the density variations in the early universe that eventually grew, under the influence of gravity and dark matter, into the cosmic web. The seeds of every galaxy, every cluster, every filament and void in the observable universe are written in those tiny temperature variations, in that ancient light that has been traveling for nearly 14 billion years and now fills the intergalactic medium with its cold, faint, nearly featureless glow. But the cosmic microwave background is not permanent. As the universe continues to expand, the wavelength of this background radiation continues to stretch. It is already in the microwave range, far below the frequencies visible to human eyes. As the expansion continues, it will shift to longer and longer wavelengths, into the radio range, and eventually to wavelengths so long that detecting them would require instruments larger than any structure gravity could hold together. The background will not disappear suddenly. It will fade, gradually over timescales that dwarf the current age of the universe, until it becomes effectively undetectable, a signal so faint and so stretched that it carries almost no information about the universe that produced it. When the cosmic microwave background fades beyond detection, the universe will have lost one of its most fundamental records. The light that was released at the moment of recombination, the light that carries the imprint of the early universe's structure, the light that has been the primary evidence for our understanding of cosmic history, will be gone, not destroyed, just stretched into silence. The universe will have erased, through its own expansion, the most direct evidence of its own origin. This is a pattern that repeats at every scale and every era of cosmic history. The universe produces records, and then the universe erases them. The light from the first stars, the population 3 stars that formed from the primordial hydrogen and helium of the early universe, has long since been redshifted beyond easy detection. The light from the earliest galaxies is accessible only to the most powerful telescopes, and only barely. As the universe ages and expands, the light from progressively more recent eras will be redshifted beyond detection, and the observable history of the cosmos will compress into a shorter and shorter window, a narrower and narrower slice of time that any observer can directly examine. In the far future, an observer in the merged remnant of the local group, surrounded by the expanding void that has swallowed all other galaxies beyond the horizon, will have access to a universe that appears, from their perspective, to consist of a single large galaxy surrounded by emptiness. They will have no direct observational evidence that other galaxies ever existed. The cosmic microwave background will be undetectable. The light from distant galaxies will have long since faded beyond any instrument's reach. The expansion of the universe will be invisible to them, because there will be nothing left to observe receding. The universe will appear, to that future observer, to be static, isolated, and eternal, a single island of matter in an infinite void, with no evidence of the vast and complex history that preceded it. This is perhaps the most quietly devastating implication of the accelerating expansion. It does not merely isolate the future universe, it erases the evidence of the past universe. A civilization that arises in the far future, inside one of these isolated gravitational islands, will have no way of knowing that the universe was once connected, once populated with hundreds of billions of galaxies, once filled with the light of a cosmic web that spanned billions of light years. They will look out into the void and see nothing, and they will have no reason to suspect that anything was ever there. The universe will have hidden its own history from its own inhabitants. We are fortunate, in a sense that carries no comfort, to exist in the current era. We exist at a time when the universe is still young enough, and the expansion still slow enough relative to the distances involved, that we can observe the cosmic web, measure the cosmic microwave background, detect the light of galaxies billions of light years away, and piece together the history of the cosmos from its beginning to the present. We exist in the window of cosmic legibility, the era during which the universe is still readable, still showing its structure, still allowing its inhabitants to understand something of what it is and where it came from. That window is closing, not quickly, not on any timescale that matters to human civilization in any practical sense, but it is closing. The universe is becoming, with every passing era, less legible, less of its history is accessible, less of its structure is visible, less of its extent is reachable. The window of cosmic legibility is a temporary feature of a particular moment in the universe's history, and we happen to exist within it, and the fact that we can look out and see what we see is not a permanent condition. It is a privilege of timing, a consequence of being born into the right era of a universe that will not always be this open, this visible, this available. But it gets worse, because even within the current era, even within this window of relative legibility, the universe is already showing signs of the isolation to come. The galaxies beyond the local group are already receding. The most distant galaxies are already beyond the cosmic horizon in the sense that no signal we send today will ever reach them. The expansion is already carrying parts of the universe beyond the reach of any future communication. The isolation is not a future condition. It is a present condition, already underway, already irreversible, already shaping the boundaries of what can ever be known. And the dark energy that is driving this isolation is not a force that acts on matter from outside. It is a property of space itself, woven into the fabric of the universe at every point, present in every cubic meter of the void, pushing outward with a pressure that does not diminish as space expands because it is not diluted by expansion. It is the energy of the vacuum, the baseline energy of empty space, and it is everywhere, always in every direction, at every scale above the gravitational binding scale of local structures. It is the most pervasive force in the universe, and its effect is to make the future more isolated than the present, and the present more isolated than the past. The universe began in a state of extraordinary density and uniformity, a hot, dense plasma in which every point was in causal contact with every nearby point, in which the universe was, in a sense, maximally connected. From that initial state of connection, the universe has been expanding and cooling and differentiating, producing structure and complexity and light, but also continuously increasing the distances between things, continuously reducing the fraction of the universe that any given point can observe or influence, continuously moving toward a state of greater isolation and lesser connection. The arc of cosmic history, from the hot, dense beginning to the cold, empty future, is an arc from connection to isolation, from the moment when everything was in contact with everything nearby, to the moment when almost nothing is in contact with anything else, from the moment when the universe was a single, coherent communicating system, to the moment when it is a collection of isolated fragments, each one unable to know that any other fragment exists. This arc is not a tragedy in any human sense. The universe does not experience loss. It does not mourn its own increasing isolation. It does not remember what it was or anticipate what it will become. The arc is simply the direction of a physical process, the consequence of the laws of physics applied to the initial conditions of the universe over the full span of its history. But for any mind capable of understanding it, the arc carries a weight that is difficult to set aside. The universe is moving, inexorably and without exception, from a state of greater connection to a state of lesser connection, and the direction of that movement does not reverse. Consider what it means for the concept of observation itself. Observation requires a signal. A signal requires a medium through which to travel. In the current universe, light is the primary medium of cosmic observation, and light can travel across billions of light years, carrying information about the state of distant objects to any observer patient enough to wait for it. But in the future universe, the medium of observation is being compromised. The expansion of space is stretching the signals, reducing their energy, shifting their frequencies beyond detection. The universe is not merely becoming harder to observe. It is becoming, in a fundamental physical sense, less observable. There is a concept in information theory about the capacity of a channel to carry information. A channel with finite bandwidth can carry only a finite amount of information per unit time. The universe, as a channel for cosmic observation, has a bandwidth that is determined by the energy and frequency of the photons that carry information across it. As the expansion redshifts those photons to lower and lower energies and longer wavelengths, the bandwidth of the cosmic channel decreases. The universe is becoming, in an information theoretic sense, a lower bandwidth system. Less information can be transmitted across it per unit time. Less of what happens in one place can be communicated to another place. The universe is losing its capacity to know itself. This is not a metaphor. It is a physical consequence of the expansion of space acting on the electromagnetic radiation that carries information across cosmic distances. The universe is a communication system, and the communication system is degrading. Not because anything is broken, not because any law of physics is being violated, but because the expansion of space is a physical process that has physical consequences for the propagation of signals, and those consequences accumulate over time in a direction that reduces the connectivity and legibility of the cosmos. And within the isolated gravitational islands of the far future, the story of degradation continues at a smaller scale. The stars within those islands are aging. The most massive stars, which burn brightest and hottest, have already died, long before the era of isolation. The medium-mass stars, like the Sun, will die within the next several billion years, leaving behind white dwarfs that cool slowly over trillions of years. The low-mass red dwarf stars will persist for tens of trillions of years, burning dimly and slowly, the last fires of a universe that is running out of fuel. But even the red dwarfs will eventually exhaust their hydrogen. The process of stellar nucleosynthesis, the fusion of hydrogen into helium and heavier elements that powers every star, requires hydrogen as its primary fuel. The universe began with a large supply of hydrogen, produced in the first few minutes after the beginning in a process called Big Bang nucleosynthesis. That hydrogen has been the fuel for every star that has ever burned. But it is a finite supply, and it is being consumed, and it is not being replenished. The universe does not produce new hydrogen. It converts hydrogen into heavier elements through stellar fusion, and those heavier elements are not easily converted back. The fuel supply is running down, and when it is gone, no new stars can form. The era of star formation is already past its peak. The universe formed stars most rapidly in the first few billion years of its history, when the gas supply was abundant and the conditions for collapse were favorable. Since then, the rate of star formation has been declining. The universe is forming fewer new stars per year than it did in its youth, and the trend is downward. The current era is not the height of cosmic creativity. It is the long, slow decline from a peak that has already passed. This is another thing the night sky hides from you. The stars you see are not evidence of a universe at the height of its powers. They are evidence of a universe that has already passed its most productive era and is now in a phase of gradual, irreversible decline. The light you see is the light of a cosmos that is burning through its remaining fuel, producing fewer new stars each billion years, moving toward a future in which the rate of star formation approaches zero and the universe becomes, star by star, darker. The darkness comes not all at once, but in stages. First, the massive stars die. The blue giants and supergiants that burn so brightly they are visible across billions of light years, but exhaust their fuel in millions of years. Then the medium stars, the yellow and orange dwarfs that burn for billions of years and produce the stable, long-lived environments that may be necessary for complex chemistry and life. Then the red dwarfs, the dim, cool, patient stars that will outlast everything else, burning for tens of trillions of years before finally exhausting their fuel and fading to cold, dark remnants. After the last red dwarf fades, the universe will contain no more stars, no more fusion, no more stellar light, no more. The gravitational islands will be populated by the remnants of stellar evolution, white dwarfs, neutron stars, black holes, and the cold, dark bodies of planets and asteroids and other objects that never achieved fusion. The universe will be a dark place, lit only by the faint glow of cooling white dwarfs and the occasional burst of energy from matter falling into black holes. The white dwarfs will cool over timescales that are difficult to express. A white dwarf is the dense, hot remnant of a star's core, supported against gravitational collapse not by fusion, but by the quantum mechanical pressure of electrons. It has no internal energy source. It simply radiates its stored heat into the surrounding space, cooling slowly, over trillions of years toward the temperature of the surrounding universe. Eventually, a white dwarf cools to the point where it no longer emits significant radiation. It becomes a black dwarf, a cold, dark, dense object that is effectively invisible, a remnant of a star that burned for billions of years and is now indistinguishable from the surrounding darkness. The timescale for a white dwarf to cool to a black dwarf is longer than the current age of the universe by many orders of magnitude. It is so long that, as far as current understanding suggests, no black dwarfs yet exist. The universe is not old enough. Every white dwarf that has ever formed is still warm enough to glow, at least faintly. But in the far future, the universe will be populated by black dwarfs, cold and dark and silent, the final remnants of the stellar era, drifting through the expanding void in the gravitational islands that are their only remaining home, and the black holes. The black holes will outlast everything else. They will outlast the stars, the white dwarfs, the neutron stars, the black dwarfs. They will persist, growing slowly as they consume whatever matter comes within their reach, for timescales so vast that the era of stars, the entire period from the first star to the last red dwarf, will seem like a brief opening chapter. The supermassive black holes at the centers of galaxies, with masses millions or billions of times that of the Sun, will take the longest to evaporate. Their evaporation timescales are numbers that require scientific notation to express, numbers that have no intuitive meaning, numbers that make the current age of the universe look like an instant, but they will evaporate. The process by which black holes lose mass, a quantum mechanical effect that produces a slow trickle of radiation from the region just outside the event horizon, is real and irreversible. It is slow beyond any human comprehension of slowness, but it is continuous, and over sufficient time, it will reduce even the most massive black hole to nothing. The black hole will shrink, slowly at first, and then faster as it loses mass, and the evaporation rate increases, until in its final moments it releases its remaining mass in a brief burst of radiation and disappears, leaving behind only the empty space that was once inside it. When the last black hole evaporates, the universe will contain no more macroscopic structures, no more objects of any significant size or mass. The matter that once formed stars and planets and galaxies will have been converted, through the long chain of stellar evolution and black hole evaporation, into radiation, into photons of various wavelengths spreading through the expanding universe, redshifting to longer and longer wavelengths, losing energy, becoming less and less capable of interacting with anything. The universe will be a sea of photons and perhaps a scattering of fundamental particles, electrons and positrons and neutrinos, and whatever other stable particles the laws of physics permit, all separated by distances so vast that interactions between them become vanishingly rare. The universe will be, in every meaningful sense, empty, not the emptiness of the intergalactic medium, which is empty by human standards, but still contains a few atoms per cubic meter. The emptiness of the post-black hole universe will be something qualitatively different, a near-perfect void in which the average distance between any two particles is so large that the concept of proximity loses meaning, and the expansion will continue. The universe will continue to grow, carrying these last particles and photons apart from each other, increasing the distances between them, reducing the frequency of any interaction to something approaching zero. The universe will approach, asymptotically, a state of perfect uniformity, perfect emptiness, perfect silence, not a state it will ever fully reach, because the approach is asymptotic and takes infinite time, but a state it will approach ever more closely, forever, without reversal, without exception, without end. This is the heat death, not a moment, not an event, a condition that the universe approaches without ever quite arriving, a limit that recedes as the universe advances toward it, an asymptote that defines the direction of all future history without ever being reached. The universe will spend an infinite future approaching a state of maximum entropy, minimum structure, minimum difference, minimum possibility, and it will never stop approaching it, and it will never arrive, and nothing will ever change that direction. The heat death is not the end of the universe. It is the end of the universe's ability to do anything. The universe will continue to exist, in the sense that space will continue to expand, and particles will continue to drift through it. But existence without process, without change, without difference, without event, is a kind of existence that has no meaning in any framework built by minds that evolved in a world of constant change and process. The universe will exist, but it will be, in every sense that matters to any conceivable observer, as if it did not. And here, at the edge of this vast and silent future, you begin to feel the full weight of what the expanding universe means. It is not merely a physical fact about the geometry of space. It is a statement about the ultimate fate of everything that has ever existed or will ever exist within it. Every star that has ever burned, every planet that has ever formed, every complex structure that has ever assembled itself from the raw material of the cosmos, every process that has ever occurred, every event that has ever taken place, all of it is part of a system that is moving without exception and without reversal toward a state of maximum entropy, minimum structure, and absolute isolation. The universe is not building toward anything. It is not progressing toward a goal. It is not moving toward greater complexity or greater richness or greater meaning. It is moving toward the opposite of all those things, toward simplicity, toward uniformity, toward silence. The complexity and richness of the current universe are not the destination. They are a temporary condition, a brief flowering in the middle of a long decline, a moment of relative order in a process whose ultimate direction is toward disorder, and the brief flowering is already past its peak. The universe formed stars most rapidly in its youth. It produced the most complex chemistry in its middle age. It is now in a phase of gradual decline, forming fewer stars, consuming its remaining fuel, losing its most distant regions to the expanding horizon, moving toward the long, dark, silent future that the laws of physics have written for it since the beginning. You are here, in this moment, in this brief window of cosmic legibility, surrounded by the light of a universe that is still, for now, producing that light. The stars above you are burning. The galaxies are still visible. The cosmic web is still intact, at least at the scales you can observe. The universe is still, in this moment, a place of relative richness and connection, but the direction of travel is fixed, and the destination is not richness. It is not connection. It is not light. The destination is the void. Not the void as a dramatic ending, not the void as a catastrophe or a collapse or a sudden darkness. The void as a slow, patient, irreversible condition that the universe is approaching with every passing moment, that it has been approaching since its beginning, and that it will continue to approach for a duration that has no meaningful upper limit. The void is not coming. The void is already here, in the spaces between galaxies, in the expanding distances between clusters, in the cosmic horizon that is already carrying parts of the universe beyond the reach of observation. The void is the dominant condition of the universe right now, and it is becoming more dominant with every passing moment. And the light, the beautiful, deceiving light of the night sky, is not evidence against this. It is evidence of the exception. It is evidence of the rare, temporary, locally concentrated pockets of matter and energy that happen, in this particular era of cosmic history, to be producing photons in wavelengths that human eyes can detect. The light is the anomaly. The dark is the rule. And the rule is winning, slowly and without drama, in the way that rules always win, not through force, but through patience. Patience is not a quality we typically assign to physical processes. Patience implies waiting, implies awareness of time passing, implies some kind of intention behind the waiting. The universe has none of these things. It does not wait. It does not intend. It simply proceeds, following the logic of its own laws, indifferent to the structures it produces and equally indifferent to the structures it dissolves. But if you were to describe the character of the process by which the universe moves toward its ultimate condition, patience would be the closest word. Not the patience of a predator waiting for prey, the patience of a tide, slow, continuous, without urgency, without pause, without any possibility of being stopped or redirected by anything within the system it is reshaping. The tide metaphor breaks down quickly because tides reverse. The process the universe is undergoing does not. There is no returning wave. There is no high tide followed by a low tide followed by a high tide again. There is only the one direction, the one motion, the one trajectory that the laws of thermodynamics have written into the fabric of reality since the moment the universe began. Every increase in entropy is permanent. Every dispersal of energy is irreversible. Every galaxy that crosses the cosmic horizon is gone forever. The universe does not cycle. It does not breathe in and out. It exhales continuously without ever inhaling again. This asymmetry, the fact that time has a direction, that entropy increases and does not decrease, that the universe moves from order toward disorder and not the reverse, is one of the deepest and most poorly understood features of physical reality. The fundamental laws of physics at the level of individual particles and interactions are largely time-symmetric. They work the same way forward and backward. A collision between two particles looks the same whether you run the film forward or backward, and yet at the macroscopic level, at the level of stars and galaxies and the universe as a whole, time has a clear direction. Things age, things cool, things disperse. The film does not run backward. The reason for this asymmetry is connected to the initial conditions of the universe. The universe began in a state of extraordinarily low entropy, a state of high order, high concentration, high temperature, high density. The Big Bang was not an explosion into pre-existing space. It was the beginning of space itself and the beginning of time. and the beginning of the thermodynamic arrow that has been pointing in one direction ever since. The universe began in a condition so ordered, so concentrated, so far from equilibrium, that the entire subsequent history of the cosmos, all 14 billion years of it, has been the process of that initial order dispersing, that initial concentration spreading, that initial temperature difference smoothing out. We are living in the middle of that dispersal. The stars are part of it. The galaxies are part of it. The cosmic web is part of it. Every structure in the universe is a temporary eddy in the flow of entropy, a local concentration of order that exists because the overall dispersal of energy from the initial state has not yet reached its final condition. The stars burn because there is still a temperature difference between their cores and the surrounding space. The galaxies rotate because there is still angular momentum from the initial conditions of their formation. The cosmic web exists because there are still density differences between the filaments and the voids. All of these structures are temporary. All of them are being slowly erased by the same process that created them, the process of entropy increasing, of differences smoothing out, of the universe moving toward the equilibrium it has been approaching since its first moment. And the expansion of space accelerates this process in a particular way. By continuously increasing the volume of the universe, the expansion dilutes the energy density of everything within it, except for the dark energy, which as a property of space itself, maintains a constant energy density as space grows. The radiation that fills the universe, the photons of the cosmic microwave background and the light from stars and galaxies, becomes less dense as the universe expands. Its energy spread across a larger and larger volume. The matter becomes less dense as well. The same amount of mass distributed across an ever-growing space. Only the dark energy remains constant in density, and it is this constancy that makes the expansion accelerate rather than decelerate. The dark energy is, in a sense, the universe's own expansion feeding on itself. As space grows, the total amount of dark energy grows with it, because dark energy is proportional to the volume of space. More space means more dark energy, which means faster expansion, which means more space, which means more dark energy. It is not a runaway process in the sense of becoming infinite in finite time, but it is a self-reinforcing process, a feedback loop built into the geometry of the universe, and its long-term consequence is an expansion that never stops and never slows, that carries the universe toward its ultimate condition of maximum volume, minimum density, and absolute isolation. Some theoretical frameworks suggest that the dark energy could change over time, that it might not be a true cosmological constant, but something more dynamic, a field that evolves, that could in principle increase or decrease. If it were to increase sufficiently, the expansion could accelerate so dramatically that it would eventually overcome not just the gravitational bonds between galaxy clusters, but the bonds between individual galaxies, then between stars, then between planets, then between molecules, then between atoms, then between subatomic particles, tearing apart every structure in the universe in a final catastrophic expansion called the Big Rip. In this scenario, the universe would end not in a slow fade but in a violent unraveling, every structure destroyed in a finite time as the expansion rate diverges to infinity. But the Big Rip is not the most likely scenario given current observations. The dark energy appears, as far as measurements can determine, to be consistent with a true cosmological constant, a fixed energy density of empty space that drives a steady acceleration rather than a diverging one. The most probable future, based on current understanding, is not the Big Rip but the slow, patient, asymptotic approach to maximum entropy that has been described. Not a violent ending but a quiet one. Not a dramatic finale but an endless diminuendo. A gradual fading of everything that once made the universe a place of structure and light and event. But it gets worse, because even the quiet ending is not as simple as it sounds. The approach to maximum entropy is not a smooth, featureless decline. It is punctuated by events, by processes that occur on the vast timescales of the far future, and that are, in their own way, as dramatic as anything in the current universe, even if they occur in a context so empty and so cold that the word dramatic loses most of its meaning. Consider the fate of the matter within the isolated gravitational islands of the far future. After the stars have died and the white dwarfs have cooled to black dwarfs and the neutron stars have settled into their cold, dense configurations, the matter within these islands does not simply sit still. It continues to interact slowly, through gravity and through the occasional quantum mechanical process. The orbits of objects within these islands are not perfectly stable. Over vast timescales, gravitational interactions between objects cause some to gain energy and be ejected from the island entirely, while others lose energy and sink toward the center. The island slowly evaporates, losing mass to the surrounding void as objects are ejected one by one, while the remaining mass concentrates toward the center. This process, called gravitational evaporation, operates on timescales that are almost incomprehensibly long, but it is real and it is inevitable. Over sufficient time, most of the mass in a gravitational island will be ejected into the surrounding void, leaving behind a dense central remnant, likely a massive black hole, surrounded by a much smaller and more diffuse collection of objects that have not yet been ejected. The island shrinks, the void grows. The matter that was once part of a galaxy, that was once part of a cosmic web, that was once part of a universe full of structure and light, drifts alone through an expanding emptiness, separated from everything else by distances that grow larger with every passing moment. And the protons that make up the nuclei of atoms, the fundamental building blocks of all ordinary matter, may not be stable forever. Certain theoretical frameworks, extensions of the standard model of particle physics, predict that protons decay over timescales that are extraordinarily long but finite. The predicted timescale for proton decay, if it occurs, is far longer than the current age of the universe, longer than the era of stars, longer than the era of black holes. But if protons decay, then all ordinary matter is temporary. Every atom, every molecule, every planet, every cold dark remnant of a star, every object in the universe made of ordinary matter will eventually dissolve into lighter particles and radiation as its constituent protons decay one by one. Proton decay has not been observed. It may not occur. The theories that predict it are not confirmed, but the possibility exists, and if it is real, it adds another layer to the story of the universe's long decline. Not only will the stars burn out and the black holes evaporate, but the very matter that remains after all of that, the cold dark remnants, the ejected objects drifting through the void, will itself eventually dissolve, its protons decaying into positrons and pions and ultimately into photons and lighter particles, until nothing made of ordinary matter remains anywhere in the universe. The universe would then contain only the products of these decays, photons and leptons and whatever other stable fundamental particles the laws of physics permit, all separated by distances so vast that interactions between them are effectively impossible, all redshifting to lower and lower energies as the universe continues to expand. The universe would be, in the most literal sense, a sea of almost nothing, expanding forever, cooling forever, approaching but never reaching the absolute zero of temperature and the absolute uniformity of maximum entropy. This is the destination, not a wall, not a boundary, not a moment of ending, a condition of near nothingness that the universe approaches asymptotically forever, without arrival. A universe that continues to exist but in which almost nothing happens, almost nothing changes, almost nothing remains close enough to anything else to interact. A universe that is, for all practical purposes, dead, even though it continues, technically, to exist. And here is the thing that makes this more than a scientific description. Here is the thing that makes it something you have to sit with, something that resists easy dismissal. The universe that is heading toward this condition is the same universe that produced somewhere in its middle history the conditions for complexity, for chemistry, for planets, for the slow, improbable process by which matter organized itself into structures capable of asking questions about the universe they were part of. The universe that is heading toward maximum entropy and absolute isolation is the same universe that, for a brief moment in its long history, contained something capable of looking up at the night sky and feeling wonder. That capacity for wonder is itself a product of the universe's thermodynamic history. It exists because the universe began in a state of low entropy and has been dispersing that entropy ever since. And the dispersal of entropy drives the processes that power stars, that warm planets, that enable chemistry, that make possible the biological processes that produce nervous systems capable of perception and thought. Wonder is a thermodynamic phenomenon. It is what happens when entropy dispersal produces, as a temporary byproduct, a structure complex enough to model the universe it is part of. And that structure, like every other structure in the universe, is temporary. The complexity that produces wonder is a local, temporary concentration of order in a universe that is moving toward disorder. It is an eddy in the flow of entropy, a brief and improbable organization of matter and energy that will, like every other organization of matter and energy in the universe, eventually dissolve back into the surrounding disorder. The wonder is real. The complexity is real, but neither is permanent, and neither is the direction the universe is moving toward. This is not a comfortable thought. It is not meant to be. The universe does not arrange itself for the comfort of the structures it temporarily produces. It follows its laws, and its laws lead where they lead, and where they lead is not toward the preservation of complexity or the perpetuation of wonder. Where they lead is toward the void, toward the silence, toward the condition of maximum entropy that is the universe's ultimate and inevitable destination. But there is something in this that goes beyond mere discomfort, something that touches a deeper unease. Because the universe's trajectory toward isolation and entropy is not just a fact about the physical future, it is a fact about the nature of existence itself, about what it means to be a structure in a universe governed by these laws. Every structure that exists, every pattern that forms, every complexity that emerges, does so against the background of a universe that is continuously working to dissolve it. Not through any active opposition, not through any force directed specifically at complexity, but through the simple, universal, inescapable tendency of entropy to increase, of order to disperse, of differences to smooth out. Existence, in this universe, is always temporary, always local, always contingent on conditions that will not persist. The stars exist because the conditions for nuclear fusion exist, and those conditions will not persist forever. The galaxies exist because the conditions for gravitational collapse and star formation exist, and those conditions are already declining. The complexity that produces minds capable of understanding this exists because the conditions for biological evolution and neurological development exist, and those conditions are tied to the existence of stable stars and warm planets, which are themselves temporary features of a universe in decline. Everything that exists is a temporary structure in a universe that is moving away from the conditions that made it possible. Everything that is here now will eventually not be here, not because it will be destroyed by any specific event, but because the universe is moving toward a condition in which the energy and the order and the differences that make it possible will no longer exist. The universe is not hostile to complexity. It is simply indifferent to it, and its indifference takes the form of a slow, patient, irreversible movement toward a condition in which complexity is impossible, and the movement is already well underway. The universe is already past the peak of its star formation rate. It is already losing galaxies to the cosmic horizon. It is already in the long, slow decline from the relative richness of its middle history toward the absolute poverty of its ultimate condition. The decline is not visible on human timescales. It is not visible on the timescale of recorded history, or of the existence of the human species, or even of the existence of the Earth, but it is real, and it is continuous, and it is the direction in which the universe is moving and has been moving since its first moment. You look at the night sky and you see light, you see structure, you see what appears to be abundance and permanence and the suggestion of a universe that is, in some fundamental sense, on your side. But the light is old, the structure is temporary. The abundance is an illusion produced by the compression of vast distances into a single image by eyes that were not built to see the truth of cosmic scales. And the universe is not on your side, not because it is against you, but because it has no sides. It has only laws, and the laws lead where they lead, and where they lead is not toward you. The night sky is the most beautiful lie the universe tells. It tells it not through any intention, but through the simple physics of light and distance, and the limitations of human perception. It shows you the exceptions and hides the rule. It shows you the bright places and conceals the vast dark spaces between them. It shows you the present light and hides the future silence. It shows you the connected universe of the current era and conceals the isolated, fragmented, cooling universe of the far future that is already, in its deepest structure, the direction in which everything is heading. And the silence that is coming is not the silence of a universe that has ended. It is the silence of a universe that continues, that expands, that persists, but that has lost almost everything that once made it a place where something could happen. A universe that is, in the most precise sense, still there, but in which almost nothing is close enough to anything else to matter. A universe of maximum volume and minimum content. A universe that has achieved, through the patient application of its own laws over an incomprehensible duration, the condition of being as close to nothing as something can be without ceasing to exist. This is the fate that the physics of the universe describes, not with certainty, because certainty is not available in a domain where the timescales involved are so vast and the unknown so fundamental. The nature of dark energy is not fully understood. The question of proton decay is not resolved. The behavior of quantum gravity in the extreme conditions of black hole evaporation is not known. There are aspects of the far future that current physics cannot predict with confidence. But the broad outlines are clear, and the broad outlines point in one direction, and that direction is not toward richness or connection or light. The broad outlines point toward the void, toward the expanding emptiness, toward the cooling silence, toward the condition in which the universe, having spent all its concentrated energy and dissolved all its structures, and separated all its remaining fragments beyond any possibility of interaction, continues to exist as a vast, cold, dark, nearly empty space that expands forever without purpose, without event, without witness, without witness. That may be the most unsettling phrase in this entire story, because the universe, in its ultimate condition, will contain no observers, not because observers will have been destroyed, but because the conditions that make observers possible will no longer exist. The energy gradients that power biological processes will be gone. The stable stars that warm planets will be gone. The chemical complexity that enables life will be gone. The universe will be a place where nothing complex enough to observe it can exist, and it will continue in that condition, expanding and cooling and emptying, for a duration that has no end. A universe without witness is a universe in which nothing is known, not because knowledge has been destroyed, but because the capacity for knowledge has dissolved, along with the structures that housed it. The universe will contain no memory of what it was, no record of the stars that burned, the galaxies that formed, the complexity that briefly emerged in its middle history. The expansion will have stretched every signal beyond detection. The entropy will have dissolved every structure that might have preserved information. The universe will have forgotten itself, completely and permanently, and it will continue in that state of self-forgetting forever. And you are here now, in the brief window before the forgetting. You are part of the complexity that the universe produced in its middle history, the temporary, improbable, thermodynamically expensive complexity that is capable of looking at the universe and understanding something of what it is and where it is going. You exist in the era of cosmic legibility, the era when the universe is still showing its structure, still producing light, still allowing its inhabitants to read something of its history and anticipate something of its future. That window is not permanent. The universe is not waiting for you to finish your observations before it proceeds with its trajectory. It is proceeding now, continuously, carrying distant galaxies beyond the horizon, stretching the light of the cosmic microwave background toward undetectability, consuming the fuel of its remaining stars, increasing the entropy of every system within it. The window of legibility is open now, and it will not always be open, and nothing you can do will keep it open because the force that is closing it is not a force that acts on human scales or responds to human intentions. It is the expansion of space itself, driven by the energy of the vacuum, following the logic of the laws of physics that have governed the universe since its first moment. The universe is leaving, not dramatically, not with any announcement or any visible sign that would be legible on human timescales, but in the deep structure of its geometry, in the recession of distant galaxies, in the stretching of ancient light, in the slow consumption of stellar fuel, in the continuous increase of entropy in every system within it. The universe is moving away from the condition that makes it knowable and toward the condition that makes it silent, and the movement is irreversible, and the destination is the void. You look up at the night sky one more time. The stars are still there, the light is still arriving, the universe is still in this moment showing you something, but you know now what the showing conceals. You know that the light is old, that the sources have moved, that the distances are vast beyond any intuitive grasp, that the emptiness between the bright points is the dominant feature of the reality you are looking at. You know that the universe is mostly void, that the void is growing, that the expansion is accelerating, that the horizon is shrinking, that the future is darker and colder and emptier than the present, and that the present is already darker and colder and emptier than the past. You know that the night sky is the universe's most beautiful deception, a compression of vast separations into an image of nearness, a record of ancient light from sources that have long since moved on, a portrait of a universe that appears full and alive and permanent but is, in its true nature, mostly empty, mostly dark, mostly silent, and moving, with every passing moment, further into the condition that is its ultimate destination. The stars above you are burning. For now, the galaxies are visible. For now, the universe is legible. For now, but the direction is fixed and the patience of the void is infinite, and the light that reaches your eyes tonight is a little older, a little more red-shifted, a little more stretched by the expansion of the space it crossed than the light that reached the eyes of anyone who looked up before you. And the light that will reach the eyes of anyone who looks up after you will be a little older still, a little more stretched, a little closer to the silence that is coming, not with fire, not with collapse, not with any ending that carries the dignity of drama, with distance, with cooling, with the slow, patient, irreversible expansion of the space between everything that exists until almost nothing remains close enough to anything else to be seen, or touched, or known, or remembered. The universe does not end. It continues, and in its continuing, it becomes, with every passing moment, a little more alone. And yet you stay. You keep looking. There is something in the human posture of looking up at the night sky that resists the conclusions the night sky forces upon you. You know what you know, and still you look. You know the light is old and the sources have moved and the emptiness is dominant and the future is dark, and still something in you turns toward the light rather than away from it. This is not irrationality. It is not denial. It is something more interesting than either of those things. It is the behavior of a structure that knows it is temporary and looks anyway. That understands its own contingency and persists anyway. That has read the thermodynamic writing on the wall and has not, for all that reading, stopped being the kind of thing that looks at stars. There is no comfort in this. Do not mistake the observation for consolation. The fact that you look does not change what you are looking at. The fact that you persist does not change the direction the universe is moving. The fact that something in you reaches toward the light does not mean the light is reaching back. The universe is not moved by your attention. It does not register your presence. It does not slow its expansion because something within it has become capable of measuring that expansion. The laws of physics are not softened by the existence of minds that understand them. The void does not pause for wonder, but the wonder is real. That is the thing that cannot be dismissed, even in the context of everything else that is true. The wonder is a real phenomenon, a real event in the universe, as real as the expansion of space, or the increase of entropy, or the recession of distant galaxies. It is produced by the same universe that is moving toward silence. It is a product of the same thermodynamic processes that are driving the universe toward its ultimate condition. It is, in the most literal sense, made of the same stuff as everything else, the same particles, the same forces, the same laws. And it is here, now, in this moment, in this brief window of cosmic legibility, as real as anything the universe contains. The wonder does not redeem the silence. It does not make the void less vast or the future less dark or the expansion less relentless. It does not change the destination. But it is here, and it is real, and it is, in its own way, as remarkable as anything else the universe has produced. More remarkable, perhaps, because it is so improbable. The universe did not need to produce anything capable of wonder. It did not need to produce anything capable of modeling itself, of understanding its own history, of anticipating its own future. It produced these things anyway, as a byproduct of the thermodynamic processes that drive its evolution. And the fact that it did is not a comfort, but it is a fact. And facts deserve to be acknowledged, even when they do not comfort. You are a fact. Your capacity for wonder is a fact. Your ability to look at the night sky and feel the weight of what you are looking at, to understand something of the distances and the ages and the trajectories involved, to hold in your mind simultaneously the beauty of the light and the truth of the darkness is a fact. It is a temporary fact contingent on conditions that will not persist, housed in a structure that will not last, produced by a universe that is moving away from the conditions that made it possible. But it is a fact now, in this moment, and the moment is real even if it is brief. Brief is a relative term. The moment of cosmic legibility, the era in which the universe is still producing light and structure and the conditions for complexity, spans billions of years. The era of stars from the first to the last spans trillions. These are not brief by any human measure. They are brief only in the context of the universe's ultimate trajectory, only when measured against the incomprehensible timescales of the post-stellar era, the era of black holes, the era of evaporation, the asymptotic approach to maximum entropy that stretches forward without limit. In that context, the era of stars is a brief opening, a flash of light in a darkness that extends forever in both directions. But you are inside the flash. You are part of it. You are one of the structures that the flash produced, one of the temporary concentrations of order that the dispersal of the universe's initial low entropy has generated as a byproduct. You are here because the universe began in a state of extraordinary order and has been dispersing that order ever since. And the dispersal in this particular corner of this particular galaxy at this particular moment has produced something capable of knowing that it is here. The knowing is real. The here is real. The moment is real. And the moment is all there is because the moment is what exists. And what exists is what is real, regardless of how long it lasts or what comes after. What comes after is the void. That has not changed. The void is the destination, and the destination is fixed, and the journey toward it is already underway and cannot be reversed. But the void is not here yet. The light is still arriving. The stars are still burning. The universe is still in this moment a place where something can happen, where something can be known, where something can be felt. The void is patient. It has all the time there is. It will wait, not because it chooses to wait, but because the process that leads to it takes the time it takes, and the time it takes is vast. And in the vastness of that time, there is this moment, and this moment contains you, and you are looking up. The looking up is not a solution. It is not an answer to the questions the universe raises. It is not a response adequate to the scale of what you are confronting. It is simply what you do, what the structure that you are does, when it is placed in the presence of something vast and incomprehensible and beautiful and terrible. You look, you try to understand. You hold the understanding, imperfectly, in a mind that was not built for these scales, that evolved to navigate a world of immediate threats and local resources and social relationships, and that is now being asked to comprehend the geometry of the cosmos and the thermodynamics of eternity. The mind is not adequate to the task, but it tries, and the trying is real, and the trying is, in its own way, one of the most remarkable things the universe has produced. Because the universe has produced in you something that knows it is going to end, not just individually, not just in the sense that every organism dies, but cosmically, something that understands that the conditions that make it possible are temporary, that the universe it inhabits is moving toward a condition in which it could not exist, that the light it sees is the light of a universe in decline. The universe has produced something that can read its own death sentence and keep reading, that can understand the trajectory and keep looking anyway, that can hold the knowledge of the void and still turn toward the light. This is not heroism. It is not defiance. It is not the triumph of the human spirit over the indifference of the cosmos. Those framings are too small, too self-congratulatory, too eager to find in the human response to cosmic scale a narrative of victory that the facts do not support. The universe is not defeated by your looking. The void is not held back by your wonder. The expansion does not slow because you understand it. The framing of heroism requires an adversary that can be overcome, and the universe is not an adversary. It is a system following its laws, and its laws are not opposed to you. They are simply indifferent to you, and indifference is not something you can overcome. It is something you can only acknowledge. The acknowledgement is what matters, not because it changes anything, but because it is the honest response to what is true. The universe is vast. The universe is mostly empty. The universe is moving toward a condition of greater emptiness. The structures within it are temporary. The complexity within it is contingent. The light within it is finite. The window of legibility is closing. The void is the destination. These are the facts, and the honest response to facts is to acknowledge them, not to soften them, not to find in them a hidden comfort, not to reframe them until they seem less disturbing than they are. They are disturbing. That is appropriate. A universe that is mostly void, that is moving toward greater void, that has produced in its middle history a brief flowering of complexity, that it is now in the process of slowly dissolving, is a disturbing thing to contemplate. The disturbance is not a failure of perspective. It is not a sign that you are thinking about it wrong. It is the correct response to a correct understanding. The universe, understood honestly, is disturbing. The scale is disturbing. The emptiness is disturbing. The trajectory is disturbing. The indifference is disturbing. And the disturbance is appropriate, because the alternative, the comfortable misreading of the night sky as evidence of a universe that is full and permanent and somehow oriented toward you, is a lie, and lies, however comforting, are not adequate responses to reality. Reality is the void growing. Reality is the light aging. Reality is the expansion accelerating. Reality is the entropy increasing. Reality is the horizon shrinking. Reality is the future darker than the present and the present darker than the past. Reality is a universe that produced you as a temporary byproduct of its thermodynamic evolution and is now, with complete indifference, continuing that evolution in a direction that will eventually make you, and everything like you, and everything unlike you, impossible. And reality is also this moment, this specific, unrepeatable, thermodynamically improbable moment in which the universe contains something capable of knowing all of that and looking up anyway. The moment is real, the knowing is real, the looking is real, and the universe, for all its vastness and indifference and darkness, is also in this moment the thing that made the looking possible. The void and the wonder are products of the same universe. The silence and the light are products of the same laws. The destination and the journey are parts of the same story, and the story is not over yet, and you are in it, and the being in it is real, even if the being in it is brief. Brief. The word keeps returning. Brief is what everything is, measured against the right timescale. The life of a star is brief. The era of stars is brief. The age of the cosmic web is brief. The window of legibility is brief. Your life is brief. The existence of your species is brief. The existence of the conditions that make your species possible is brief. Everything is brief, and the briefness is not a flaw. It is not a tragedy. It is simply the nature of structures in a universe governed by the second law of thermodynamics. Everything that forms will dissolve. Everything that concentrates will disperse. Everything that burns will cool. Everything that is here will eventually not be here. The briefness is not the exception. It is the rule. And the rule applies to the universe itself, in a sense. Not in the sense that the universe will cease to exist, because the evidence suggests it will not, but in the sense that the universe as a place where things happen, where structures form and dissolve, where light is produced and absorbed, where complexity emerges and persists for a time, is a temporary condition. The universe as a dynamic, eventful, legible system is brief. What comes after? The long, cold, dark, nearly empty expansion that stretches forward without limit is not the universe in any sense that would be recognizable to anyone who has only ever known the current era. It is the universe's aftermath, its residue. The space that remains after the universe in any meaningful sense has ended. The universe ends not with a bang and not with a whimper, but with a silence so complete and so vast that the concepts of bang and whimper become inapplicable. It ends with the absence of any process energetic enough to produce a sound, any structure complex enough to produce a witness, any difference significant enough to drive any event. It ends with the void, which is not an ending in the physical sense, but is an ending in every other sense, an ending of event, of structure, of complexity, of light, of the possibility of any of these things ever occurring again. And the void will persist. That is the final fact, the one that sits beneath all the others and gives them their full weight. The void will persist, not for a long time, not for a very long time, forever. The expanding, cooling, emptying universe will continue to expand and cool and empty for a duration that has no upper limit, that does not end, that stretches forward without any boundary or any terminus. The void is not a phase. It is not a condition that will eventually give way to something else. It is the final state, the state the universe approaches and never leaves, the state in which the universe will spend, if spend is even a meaningful word in this context, the overwhelming majority of its existence. The current era, the era of stars and galaxies and cosmic webs and complexity and light, is not the universe's normal condition. It is the anomaly. It is the brief, improbable, thermodynamically expensive exception to the rule of emptiness and silence that defines the universe's ultimate state. The void is normal, the light is the exception, and the exception is ending, slowly, without drama, without any announcement, in the way that exceptions always end, by giving way gradually and irreversibly to the rule. You are the exception looking at itself. You are the brief, improbable, thermodynamically expensive complexity that the universe produced in its anomalous middle history, looking out at the universe that produced you and beginning to understand what you are looking at. You are the light becoming aware of the darkness that surrounds it. You are the structure becoming aware of the entropy that will dissolve it. You are the moment becoming aware of the silence that will follow it. And the awareness changes nothing. The universe does not respond to being understood. The expansion does not pause for comprehension. The entropy does not slow for recognition. The void does not recede because something within it has learned to name it. The awareness is real, and it is remarkable, and it is one of the most improbable things the universe has produced, and it changes nothing about the universe's trajectory. The universe will proceed, the void will grow, the light will fade, the silence will deepen, and the awareness, like everything else the universe has produced, will eventually dissolve back into the disorder from which it briefly emerged. This is the story the universe is telling, not a story of progress or purpose or meaning moving toward fulfillment. A story of a beginning that was extraordinarily ordered, a middle that was briefly and improbably complex, and an ending that is vast and dark and silent and permanent. A story that does not conclude with resolution, but with dissolution. A story that does not end with meaning affirmed, but with meaning lost, with the slow evaporation of every structure capable of holding meaning, until the universe contains nothing that could recognize meaning if it existed, and nothing that could notice its absence. The story is not over. You are in the middle of it, in the brief, bright, complex middle that will not last. The ending is coming, not soon by any human measure, but certainly, inevitably, without any possibility of prevention or reversal. The ending is written into the laws of physics, into the second law of thermodynamics, into the geometry of an expanding universe driven by the energy of the vacuum. The ending is not a possibility, it is a consequence. And consequences, unlike possibilities, do not require your consent. You did not consent to being here. You did not choose to be a temporary structure in a universe moving toward maximum entropy. You did not ask to be the kind of thing that can understand its own contingency and feel the weight of it. You were produced by the universe as a byproduct of processes that had no intention and no awareness of what they were producing. And now you are here, understanding something of what you are and where everything is going, and the understanding is yours, and it is real, and it is, in this moment, the most remarkable thing in the observable universe. Not because it will last, not because it will matter in any cosmic sense, not because the universe will be different because you understood it, but because it is here now in this moment, and the moment is real, and the understanding is real, and the universe that produced it is real, and the void that will eventually swallow it is real, and all of these things are true simultaneously, and holding them all simultaneously, without flinching from any of them, without softening any of them, without finding in any of them a comfort that is not actually there, is the most honest thing you can do in the face of what the universe actually is. The night sky above you is full of light that left its sources millions and billions of years ago. The sources have moved. Some have died. The universe has expanded in the time the light was traveling, and the sources are now farther away than the distance the light traveled to reach you. The light is a record of a past that no longer exists in the form it had when the light left it. You are looking at history, not at the present. You are looking at the universe as it was, not as it is. And as it is right now, is already different from what you see, already older, already more expanded, already further along the trajectory toward the void. The light arrives, and you receive it, and for a moment, the distance collapses, and the past becomes present, and the universe seems close and full and alive. And then you remember what you know, and the distance returns, and the past recedes back into the past, and the universe resumes its true scale, its true emptiness, its true trajectory. And the stars above you are still beautiful, and the beauty is real, and the beauty does not lie exactly, but it does not tell the whole truth either. The whole truth is larger than the beauty. The whole truth includes the void. The whole truth includes the silence. The whole truth includes the direction the universe is moving, and the destination it is moving toward, and the fact that nothing within it, including you, including the beauty itself, will be exempt from the arrival. The void is patient. It does not hurry. It does not need to. It has all the time there is, and all the time there is belongs to it, because all the time there is leads toward it, and the leading never stops, and the arrival, though it takes forever to complete, is never in doubt. The void is the most certain thing in the universe, more certain than any star, which will burn out, more certain than any galaxy, which will dissolve, more certain than any law of physics which might, in some future theory, be revised or extended. The void is the destination that the second law of thermodynamics has guaranteed since the first moment of the universe's existence, and the guarantee has never been broken, and it will not be broken, and the void will have in the end everything except this, except the moment of knowing, except the brief, improbable, unrepeatable instant in which the universe looked at itself through the eyes of something it produced and understood, however partially, however imperfectly, what it was looking at. The void will have everything except the moment, because the moment is not a thing the void can possess. The moment is not a structure that can be dissolved, or a signal that can be stretched, or a temperature that can be equalized. The moment is what it is while it is, and when it is over, and the void does not inherit it. The void inherits the space the moment occupied, but the moment itself is not inheritable. It simply was. It simply was. That is the final thing. Not a comfort, not a resolution, not a meaning that redeems the silence or fills the void or changes the destination. Just the fact of the moment, the bare, unadorned, thermodynamically improbable fact that the universe, in its middle history, produced something that knew it was here, that looked up, that understood something of the vast, cold, dark, expanding, entropy-increasing system it was part of, that held the knowledge of the void and did not look away. The stars are still burning, the light is still arriving, the universe is still in this moment showing you something, and you are still here, looking at it, knowing what you know, feeling what you feel, holding the beauty and the terror together in a mind that was not built for either, but has somehow managed both. The void is coming, the silence is coming, the darkness is coming, not tonight, not soon, but certainly, inevitably, without exception, and tonight the sky is full of light, ancient light, traveling light, light that has crossed distances your mind cannot hold, light that carries within it the history of sources that have long since moved on. It reaches you here, now, in this moment that will not last, in this window that is closing, in this brief and improbable exception to the rule of emptiness that defines the universe's ultimate condition. You look up, the light arrives, the universe continues, and somewhere in the expanding dark between the stars, in the vast and growing silence between the galaxies, in the cold and patient void that is the universe's true face and final destination, something that has no awareness and no intention and no preference continues to do what it has always done. Expand, cool, disperse, and wait. Not for you, not for anything. Just wait. In the way that the void waits, which is to say without waiting at all, without any awareness of the passing of time, without any knowledge that there was ever anything here to look up and notice that the dark between the stars is not empty space waiting to be filled, but the future arriving early, one photon at a time.